Other students, today we'll discuss about mirror formula, that is also known as mirror equation. So let us derive the equation, that is mirror equation. The equation that we derive for a mirror is valid for the plane mirror, concave mirror, or convex mirror. So whichever mirror you take, the result is valid for all three types. So let us first consider a concave mirror. This is a concave mirror, so this side is silvered, and this is the principal axis, and this is the pole of the mirror. Now this is the focus, and the equal distance over here is point C, is the center of curvature of the mirror, and this distance CP is called radius of curvature. This distance FP is called the focus, the focal length. So this is F is the focal length, and the CP is called radius of curvature. Now our aim is to find the equation. The basic meaning of the equation is to have a relations among three physical parameters, that is the focal length, this focal length, and the object distance and the image distance. That means where you keep the object. Suppose that I consider an object or a point object at the center of curvature itself. So this point is known as the point object. This is the point object is kept here. This is the object. This is the point object which is here. Now this will move towards this I, because when this moves towards the mirror, you know that the image is also formed there. So if it goes like that, it will come back in the same way. So image is found here. So you will have this image found here. This is the object, and this will be the image. The point object will have a point image, because one ray, if I consider from here, it will move straight toward the pole and it will be reflected back. This is the first ray and this is the second ray. The first ray is reflected, this is also the normal, this is also known as the normal. So the ray travels back in the same direction, comes to this point, and one ray coming from this point also meets here. So when these two rays will meet, the reflected rays will form the image. So here image is formed. Now we will consider a situation, a point somewhere else other than this center of curvature. Let us, to derive the mirror equation or formula, we will consider a point object. The point object is placed beyond the center of curvature. So I will consider a concave mirror. Now this is suppose focus, this is point is P, equal distance here is the center of curvature. I will consider a point object over here. This is the point object. Now I will see how the image is formed. Let us say that this is how the ray travels towards the mirror. Like that, it goes straight. It will obviously go to all the points in the mirror. Okay, like that. It will go to all the points in the mirror, but we'll consider only one ray, whichever direction you choose. Correct. Suppose that this is the one of the ray that is moving towards the mirror. Now this line, this point is suppose Q Q is this point, and this line is a normal. This line is normal because we know that line joining the center to the any point on the mirror is a normal. So this line is a normal, and this is the incident ray. This is the angle. Suppose that angle is theta. If this angle is theta, then it will be reflected back with the same angle theta in this direction. It will move in this direction like that. So here the image, the reflected ray is passing through the cutting the principal axis over here, and what ray will directly come in this direction and will meet here. So this is where the image is formed. So let me just tell you again how the image is formed. One ray is going from the object towards the mirror, is reflected back. This is one ray, and another ray directly coming along, moving along the axis will meet here. These two waves will meet here, and image is formed. Now we know that this distance is from here to here, from object to the pole. This is known as object distance. I'm not using proper sign conventions, then that will use later on. So it is u, obviously it is negative, okay, and this is r. This distance is f, so I'll call this distance as f, the focal length of the mirror. And when the image is formed somewhere here. This is known as V, is the final image. So basically, in mirror equation, you have to derive the relationship between U, V, and F. This is how the relations among this U, V, and F are called as mirror formula. Now, if I what angle the incident ray, the reflected ray, and the normal makes with the principal axis. Suppose that the incident ray makes an angle of alpha, the reflected ray makes an angle of this makes an angle of beta, this makes an angle of gamma with the x-axis. These rays are incident very close to this axis, so this is a magnified version, but this ray is actually striking over somewhere here. It's very close to the axis. Now here we will if this angle is theta, then this angle is also theta. So this total angle is 2 theta. Now I can use any way of getting the relations among these three quantities, but still, first I will consider the triangle. I will consider two triangles basically. One triangle is O, C, and Q. From this triangle O, C, Q, alpha and theta are the remote interior angles, and beta is the exterior angle. So in this triangle O, C, Q, okay, this theta and alpha are the remote interior angles, and beta is the exterior angle. So from exterior angle principle, from exterior angle, beta is sum of alpha plus theta. Beta will be alpha plus theta, okay, and from here we can write theta equals to beta minus alpha. This is equation number 1. Now I will consider another triangle, that is C, Q, and I. Okay, I'll consider triangle C, Q, and I. So I'll take another page. From you can see here C, Q, I, this triangle, beta and theta, because this is the angle of incidence, this is the normal, so this is also theta. This angle is also theta. So this theta and beta are the interior angles and gamma is the exterior angle. So we can write gamma is beta plus theta. Gamma is beta plus theta. So from here, theta is gamma minus beta, and this is equation number 2. What was our first equation? The first equation was theta is beta minus alpha. This is equation number 1. If you look at these two equations, the left hand side is same, that is theta, so right side will be equal. So from one and 2, we can write gamma minus beta, this one equals this one. So from here I can write 2 beta equals to alpha plus gamma. 2 beta equals to alpha plus gamma. Now because these are paraxial rays, or these are the rays which are very near to the principal axis. These rays are actually very close to this principal axis. That means the rays are actually striking somewhere very close to this part, but it has been magnified. So because this angle is, therefore this angle alpha, beta and gamma are very small angles. So this is the assumptions that we have made, that the angles under considerations alpha, beta and gamma are small angles. So if it is a very small angle, then this arc, this point Q is actually very close to this point P, somewhere here. So you could imagine now that if this point Q is very close to this point Q, so this angle is now very small. This is really alpha. Similarly, the beta and the gamma will be very small. Therefore, we will consider that in place of alpha, we can write tan alpha. In place of beta, we can write tan beta. In place of gamma, we can write tan of gamma. That way, you can write. So, and that alpha, tan alpha is this side. If I drop a perpendicular from here, if the point Q is here, then the perpendicular is very close to this point. That means the situation is something like that. I'll just try to draw here. Suppose this is O. This point is P. I draw here P. And this Q is very close to this point Q. So in this situation, if I drop a perpendicular, this is just a triangle. This is an alpha angle, and any other angle, say C or I, these are the angles. You can see this is a triangle. Tan alpha is this side by this side. Similarly, this angle can be found like that. The basic idea is to replace alpha or convert alpha in terms of this length V, U, so that because if this is OP, now you can see here OP is your U, this whole distance is U, this distance is your R, and this distance is your V. So by taking alpha as tan alpha, actually I am converting this tan alpha, this divided by this U. Similarly, this beta and the gamma are converted. This is your beta, tan beta is this side by R. Similarly, tan gamma is this side, that is PQ divided by V. So this is what we are exactly going to do here. So this is recognized as 2 tan of beta, tan of alpha and tan of gamma, because alpha, beta and gamma are very small. Now using the triangle, that tan beta will be PQ, almost to a straight line. So PQ divided by R. Beta is 2 beta is R. Okay. Now similarly, tan alpha will be PQ divided by U, and this is PQ divided by V. If I use the sign convention, using sign convention, using sign convention, I'll put all are negative. So all these are negative. So this PQ will cancel out. This is 2 by R, 1 by U, 1 by V. All are negative. So they cancel out. This is the answer. Now, as we know that R is 2F. So if I put it here, this will be 1 by F, and that is equal to 1 by V plus 1 by U. This is the mirror formula, or this is also known as mirror equation. Now, the thing is that if I have derived this expression when I have taken concave mirror, if I take convex mirror, then also I will get the same result. So that formula is valid for all types of mirrors. So concave, convex is valid. So let us take convex lens also, convex mirror, and then derive the mirror formula. And let us see if we are getting this result 1 by V plus 1 by U is 1 by F or not. So students, we will use convex mirror and derive mirror formula. So mirror formula using convex mirror. So the convex mirror is like this. Now I'll consider a point object from which the ray will, this is the object which is placed here, this is the point which is the pole, and the ray goes like this and strikes somewhere here. The point say Q. It is at that point Q. Now this ray will be reflected, but to find the direction of the reflected ray we must know the normal. So at this point, first of all you have to draw the normal, then only you can say which direction it will go. Because this is a convex mirror, suppose that this is the focal length and this is the center of curvature. Okay, suppose that this is the center of curvature. If this is the center of curvature, then we know that from the center of curvature to any point you are interested in, if you join a line, draw a line, that is the normal. So here this is the normal. This is your N normal. This ray O and this point is suppose Q, OQ, and this angle is theta. This angle is, I will use this pen. This angle is theta. Why this is theta? It is the angle of incidence, angle between the incident ray and the normal. Now it will, by the same amount theta, it will get reflected back with the same angle. And if you extend that ray in the backward direction, it will meet somewhere here. This is where the image is formed. The one ray goes like this. It's actually going in that direction, but the extended ray is meeting at this point I. Similarly, one ray goes like that and is reflected back in the same direction, which is because this is the normal. So therefore, if you extend this in the backward direction, this will meet here. So this is how you get the virtual image. Now, as usual, we'll consider that the angle are alpha, beta, and gamma. So this is your alpha. Alpha is the angle that the ray makes with the x-axis or the principal axis, and beta is the angle made by the center of curvature, this line, that is the normal with the principal axis, and gamma is the angle made by this reflected ray with the principal axis. This point is Q, this angle is theta, this angle is also theta. Okay, now if this angle is theta, this angle is also theta. You can see this is an alternate angle, this is theta, so this will be theta. Now we will consider this triangle. First of all, I will consider O, Q and C triangle from triangle OQC. What we are getting here is that in O, Q and C, the exterior angle is theta, the remote interior angles are alpha plus beta. So from here I write theta is equation number 1. Then I will consider another triangle CQI from what I will get CQI. This gamma is theta plus beta. Gamma is theta plus beta because gamma is the exterior angle and theta plus beta. So from here I will write theta as gamma minus beta. This is equation number 2. If you compare these two equations as usual, we will compare the equation and see what we are getting. And we must keep in mind that this is the object distance u, which is negative, and this distance is r, which is positive, and this distance is v, which is also positive. So we have to put that this distance and that distance as positive and this distance as negative. Now from equation 1 and 2, from you can compare this, that this is the left hand side, these are the theta angle, and the right hand side will also be equal. So alpha plus beta is gamma minus beta. So we get, so from here this is what we are getting. Again I'll use 2 tan beta as from here I'll write 2 of tan beta. What is tan beta? You can see here tan of beta, that means basically in this triangle this distance by this distance, but basically this distance is nothing but PQ because this ray is very close to this as we discussed last time. So this distance by this distance, that means PQ divided by R. R, and this is tan gamma. You can see here what is gamma is this PQ divided by V, minus what is tan alpha? Tan alpha is this PQ divided by U. PQ divided by U. But with sign convention, R is positive, V is positive, U is negative. If you put this convention over here, this will become, this PQ cancels, 2 by plus R, 1 by plus V, minus 1 by minus U. So from here it is 2 by R equals to 1 by U. From here I can write, because R is 2F, so I will substitute R equals to 2F in the equation, so I will get 2 divided by 2F equals to 2 cancels out, 1 by F is. So this is exactly the same equation that we got last time. So what is the conclusion? The conclusion is that whether you take a concave mirror or convex mirror, the mirror formula comes out to be 1 by V plus 1 by U is 1 by F. Okay, this is the mirror formula. Thank you.